Hello everyone, we are the DataMimers group. To tackle the four main sub-challenges within the publication mining track, we took two main approaches. The first one is the probabilistic topic modeling, and the second one is the social network analysis. So to first identify experts in a particular field within this publication corpus, we constructed several graph-based networks. For example, we constructed direct citation networks, co-citation networks, and co-author networks using citation and authors data. After constructing these networks, we further filtered them to include only those articles that had at least 100 citations and those authors that have at least 100 publications. Here are snapshots of some of these networks that were constructed to identify key experts. This is an example of a co-citation network. We also applied community detection algorithms on the filtered networks and also computed centrality measures to identify key experts in a particular field. This is an example of a co-author network that was constructed. Next, to identify hidden topics within this enormous publication corpus, we implemented the dynamic topic modeling, which is an extension to LDA that stands for Latent Dirichlet Allocation. We implemented a Python wrapper around a C++ original implementation by Dr. Blay, and then visualized the outputs using Tableau. This is a dashboard where you can visualize the topic probabilities across several year ranges, starting from 1950 to 2010. We also identified top documents that discuss a particular topic. And we can also visualize how the topics have evolved over time using the line graphs that are constructed using Tableau. We also finally took the output of the DTM and added the affiliation data and used Tableau to visualize the geographic distribution of topics over the world map.
The main issue faced here was the lack of consistency between admin levels in the affiliations data. Publications would report by zip, state, or countries. Due to the inconsistencies in the affiliations data, 7.5% of the publications for 2016 were not able to be geocoded. Working with large data sets that do not have uniform attributes like this can prove to be difficult to format so that they can be accurately mapped.
Another challenge we faced was our computational power, or lack of it. We all started on laptops that did not have very much power, and then later through the data challenge we were able to gain access to a more powerful machine in which we were able to run multiple instances of our program and speed up the process. What we learned from this is that big data requires powerful machines.
One of the hardest challenges when working with big data is cleaning up the raw data. Often there will be errors in a particular row or something that causes the program to crash, and you lose any progress that you had while running that program. So what we found is that it's best to account for all the errors you can beforehand instead of letting your computer running into the errors to find the errors. Also, something that helps is using Python's try-catch-it statements so that you can run past errors and continue to get your data, and also so that you can find the errors and then go back and fix them later.